Hello students, welcome to the lecture number 3 of the topic light, reflection and refraction. In lecture 1 we discussed about the light and the topic reflection, and then we discussed about the laws of reflection, that there are two laws. And in lecture number 2 we discussed about the formation about the reflection in spherical mirror. That means given the incident ray, for a given incident ray, what should be the path of a reflected ray, that we have discussed. Okay, if you can find the path of a reflected ray, then you can you can analyze the image formation. Okay, and that is what we will discuss in today's lecture. And today's lecture is very important as exam point of view, because most of the time you find question from this lecture, because you will be given a question to find either position or size or the nature of the image. We will discuss in detail. And so from here you should start targeting exam, answering questions in exam. Okay, because most of the previous year questions suggest that this lecture is very important, because you will find, definitely you will find a question from this lecture. Okay, so be prepared and you should have attention in this lecture. Okay, going to one by one. So now first we need to understand what is the concept of image formation. I had told in lecture number 2 that image formation is nothing but the intersection of reflected rays. Okay, the intersection of reflected rays. See, like an image, and here I have written, an image is formed when two or more reflected rays intersect. Like suppose this is object. Okay, now this is the object. Yeah, let me have the pencil or pen. Yeah, so this is the object. Okay, now so to find the intersection point, I need at least two reflected rays. At least two reflected rays. So this is one incident ray. Then this is parallel to the principal axis, and we had a discussion. When the incident ray is parallel to the principal axis, this is the principal axis. Okay, the reflected ray will pass through the focus. And next we need to find we need another reflected ray, because we need to find the intersection point. So we should have another incident ray. So we have another incident ray, and the reflected ray is this one. So this is the intersection point. This is the This is the incident ray, and this is the reflected ray. Okay, now this is the intersection point. So this will be your image. Okay, now you can see this is the image. Okay, so this is the concept of image formation. So you need, remember, you need two reflected ray, and two reflected ray to find the intersection point, and that intersection point will give you the formation of image. Okay, remember all these things. Now, concept of image formation in convex mirror. Okay, so in convex mirror, see, in convex mirror we have image here. In case this was case of concave mirror, and in case of convex mirror, see, this is the mirror, and this is object, this is incident ray, and this is reflected ray. We have already discussed this in lecture 2, how will be the reflected ray. And now what we have to do, remember, in case of convex mirror, you need to extend the reflected ray in the back of the mirror. Remember, it is important for you to understand that the reflected rays never meet in convex mirror. Okay, so for that matter, it is very important for you, and it is necessary for you to extend the reflected ray in the back of the mirror. Okay, see, here we have extended. Okay, and now we have another incident ray, and we have the corresponding reflected ray, and this is we have extended. So now this is the point of image formation. This is the intersection point. So now the image is formed here. Okay, so these are the two things. Now if you see description of the image, when you find the image, what are the properties of the image you have to describe. What are the properties of the image? What are the properties of the image you have to describe? Now, description. The description first point is nature of the image. Okay, so like and when we talk about the image, the reference is object. Okay, this is the object. Suppose this is the object. This is the object. Now, an image, when the image is formed, can be in the same direction or in the opposite direction. If it is in the similar direction to the object, then it is erect image. Then it is erect image. And if it is in opposite direction, then it is inverted image. So when we are when we are finding the image, when we are seeing the image, you have to first understand whether the image is erect or inverted. That is point number one. So an image can either be erect or inverted. If the direction of the image is same as that of the object, then the image is said to be erect. And what second nature of the image is whether the image is real or virtual. Okay, this point I have already discussed in the case of suppose here, see here the reflected rays are actually meeting here. There is actual intersection of reflected rays. So that means really meeting. The word real, get that point. The word real. There is a real intersection point of the reflected rays. So the image is real. In case of suppose in this example, okay, in this example the reflected rays are actually not intersecting. But if we extend, then we are finding an intersection point. That means we have to extend the reflected rays in opposite direction, and that is nothing but a virtual point of intersection. That is the virtual intersection. So that's why the image formation is called virtual. Actually, there is no real intersection. We are extending in opposite direction so that we can get an intersection point. That means it is a virtual intersection. So the image can be real or virtual. That is what I have discussed. If the reflected rays are converged and meet at one point, then the real image is formed. If the reflected rays are diverged, okay, or diverged and are extended behind the mirror to meet at a point, then it is a virtual image. Okay. Now, second, so whenever a question is asked to you, then first point you have to find the nature of the image. And under the category of nature, there are 2 points you have to find, whether it is erect or inverted, and second point, whether it is real or virtual. These things you have to answer. Next, going to the second point, size of the image. Okay, whether the image, and remember, it's as I have already told that as I have already said that the image, whatever description you are giving for the image, that should be with respect to the object. Okay, so now going to the next point, whether with respect to the image or with respect to the object, what is the size of the image? Okay, that you have to define when the question is asked to you. So first, whether it is highly diminished, that means it is very very large, or it is diminished, sorry, very very small, that means you can say zero size or point size. Whether it is diminished in the sense smaller than the object, image is smaller than the object, or it is same, that means you can say it's very very small. Okay, this is image. Okay, can be very very small, or can be small, or can be equal, can be large, or can be highly enlarged, and this is object. Okay, so image can be highly diminished, or same, or enlarged, or highly enlarged as compared to the object. Okay, now this is second point. And third point, you have to find the position of the image. So the range of position where the image can be formed can be like in mirror. You have center of curvature, and you have focus, and you have pole. Okay, so you have to define whether the image is formed at the far away from the center of curvature, that is in the infinity, or just beyond the center of curvature, or on the center of curvature, or in between center of curvature and the focus. or on the focus. So that means you have to find a position, find the position of the image where the image is formed. So when you are discussing about the area, means range, whether it is the center or between center or without particular distance, means any numerical value of the distance, you are saying okay, the image can be between center of curvature and the focus. So that is called describing the position of the image by a range. Okay, so no numerical value is given, no exact distance is given, and on the other hand, you can also give the exact distance of the image. Okay, and we will discuss towards the end of this lecture or in the next lecture. So that thing you have to find. You have to find. So when the question of the image formation is given, you have to find the nature of the image, and you have to find the size of the image, and you have to find the position of the image. Okay. Now, so image formation of a concave mirror. So like this is, I have already told that object is always in front of the mirror. Object is always in front of the mirror. So this is mirror. So here this is the front of the object. So object can be at infinity. That means let us have some example of object position and image formation. So we have considered 6 positions, and if you just analyze this, all the image formation are covered with these 6 cases. Okay, so one thing, image can be at the infinity, or image can be at the beyond the center, just far away the center of curvature. That means beyond center of curvature. Oh, sorry, this is object, not image. Object can be at infinity. Object can be beyond the center of curvature, and object can be at the center of curvature, or object can be between center of curvature and the focus. Okay, in between, or object can be at the focus, that is 5th case, at the principal focus. Okay, and the last case, object can be between focus and the pole. Okay, these 6 conditions we will discuss, and we will find where the image is formed. Okay, for each case remember, you have to find the nature of the image, size of the image, and position of the image. Okay, let us first go with the case 1, infinity. Object is at infinity. So this is the object. Okay, see, these are incident ray. Okay, so you can see first all those, first case, this is parallel to the, you can see all the incident rays are parallel to the principal axis. So all the reflected ray will pass through the focus. That means the intersection point is the focus. That means, and what is the distance between the principal axis and that point? Is, you can say, almost 0. That's why the first point, the intersection point, is focus. That's why the image is formed with the focus, and it is at that point. That means it is very, very small, because it is almost on the principal axis. So it is highly diminished. It is real, yes, because there is a real intersection of the reflected rays, and it will be inverted. Okay, now you got it. Object at infinity. Not going to the second case, object at beyond C, that is beyond center of curvature. Now remember, whenever you discuss about the image formation, you need 2 rays, 2 reflected rays, and one reflected rays. Remember, one reflected rays must be the one incident ray must be the line parallel to the principal axis. Remember, and you need to find the other incident ray. Okay, what I said, one incident, you need 2 incident ray. You need 2 incident ray to find the point of intersection of reflected rays. Okay, and out of 2 incident ray, one incident ray is the incident ray parallel to principal axis. Okay, one incident ray is the incident ray parallel to principal axis, and second incident ray you have to find, and most of the case second incident ray will be discussed or will be decided by the next point. For example, here beyond C, okay, here you can see, as I said, one incident ray will be parallel to the principal axis, and as discussed in lecture 2, when the incident ray is parallel to principal axis, the reflected ray will pass through the focus. Okay, this is one reflected ray. And what will be another incident ray and the corresponding reflected ray? So, what is the next point after the object? That is the center of curvature. So, just consider a line passing through the center of curvature. And what will be the reflected ray? The same path in opposite direction. So, this is the point of intersection and this is the image formation. So, where is image formed? Between center and the focus. The image is formed. See, the image is formed between the center and the focus. Okay. Is it virtual or real? There is a real intersection of reflected rays. So it is real. It is real. It is erect or inverted. See, the object is in towards the upward direction and image is towards the downward direction. So it is inverted, and it is diminished because it is smaller than the object. Okay. Now, if you go to the next point is object at C. Okay, see, this point is covered, and next point is this point. Okay, so object is at C. I will not discuss in, you can see, you can understand it by the flow. Okay, here is the object at the center of the curvature. Then first line will be the line parallel to the principal axis. The corresponding reflected will pass through the focus. And what is the next point after the object? That is the focus. So another line will be passing through the focus. And what will be the reflected ray as discussed in lecture 2? The reflected ray will be parallel to the principal axis. This is the principal axis, and the image is found at the same point. Okay, the image is found at the same point. That is the center curvature. Is it real or virtual? Real, because of real intersection of reflected rays. It is inverted. You can understand that, and the size is same. Okay, so this is object at C. Then object will be between C and focus, center of curvature and focus. So one ray will be parallel to the principal axis. This ray parallel to the principal axis. The corresponding reflected ray will pass to the focus, and another ray will pass to the focus, and incident ray pass to the focus. What will be the reflected ray? That will be parallel to the principal axis. So this is parallel to the principal axis. Now the image will be large and beyond C, inverted. The image position is beyond C, right? You can see it is enlarged as compared to the object, and it is real, yes, because of real intersection, and it is inverted. Okay, if you find any difficulty, let me just contact me. I will again explain to you. Now, object next after the object between center of curvature and the focus, next will be at the focus. Okay, the object is at focus. One line, that is incident line, parallel to the principal axis, and the reflected ray will be passed to the focus. Now, what is the next point? Next point is the principal pole, but that is the angle of incidence. Those things we don't know. So one thing we can see, if we go through this line. Okay, see, this is the incident ray and this is the reflected ray. Okay, because the incident ray is, if we extend the incident ray in this direction, it looks like it is passing through the center of curvature. That means the reflected ray will pass through the center of curvature, and you can see they are almost parallel. Both the reflected ray are almost parallel. That means they will never meet, and if they meet somewhere, then it will be infinity. What do you mean? What is the infinity? Infinity is something that not possible. Okay, like infinity is counting something that we can never count, or we can never measure. Okay, so that means here we can never find the point of intersection. We can never find the distance at which at the distance where the intersection point will be. That means it is at infinity. So image is formed at infinity. Now what about the size? You can see with the image as we go towards the infinity, the image size is infinity. That means the image is highly enlarged. So it is highly enlarged. The distance between the principal axis and the intersection point is increasing. So at the infinity, the image, the size of the distance between the principal axis and the intersection point will be very large. That means the image is highly enlarged. It will be inverted and it will be real, because the actual incident rays are moving in that direction. That means if they meet somewhere in infinity, then that will be real intersection. So it is highly enlarged, real and inverted. Now last point, object is between focus and the pole. Okay, so object is between focus and one line that I have already told will be parallel to the principal axis, incident ray. This is the reflected ray, and another line will be same, that is passing to the center of curvature. Now here, see, you can see as we move to here, the distance between these two reflected rays are increasing. That means they will never meet in this direction, but I can extend them. Okay, I can extend them. If I extend them, then somewhere they will meet. That means, and here is the image found. Okay, and where is the image found? Image is found behind the mirror. And what is the size of the image? It is enlarged, larger than the object, and it is erect or inverted. Erect, because the direction of the image and direction of the object are same. Okay, and is it virtual or real? It is virtual, because the reflected ray will never meet. We have to extend them in the back side of the mirror. Okay, where they can meet. That means the image is virtual. Okay, so this is about the image formation in concave mirror. In the next lecture, is the last topic on the reflection. Okay, that is, in the next lecture we will discuss about the image formation in convex mirror and mirror formula and some problems. Okay, so these are the questions. Okay, so these are the questions you can attempt. You can attempt to solve to answer. Okay, so here are some previous questions you can answer. Okay, and these are from lecture first and second lecture. Okay, just answer them if you can. If you find any difficulty, then mail me on questionpsr@gmail.com. Okay, and next lecture we will discuss about the image formation in concave mirror, and then we will discuss about the image formation in convex mirror, mirror formula, and that will be the end of the part reflection. Okay, bye, take care.